Swayam Prabha. Digital India. Educated India.
A very good morning, good afternoon, good evening, my dear friends. Welcome back to this TQM 1 set of lecture series under NPTEL MOOC, and I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, we are starting the 28th lecture, and as you remember, we are discussing some problems related to the charts being X bar charts, R charts, which is the R chart is the range charts, and then if you do not want the range, you can definitely replace that with the standard deviation charts, provided standard deviation is known for the population, not known, and there are different combinations you can find out and find out the estimates, use those estimates to do the calculations and use the tables from where you can find out those coefficients of A1, A2, A3, B1, B2, B3, C1, C2, C3 and so on and so forth. And if you remember that where the fact part we did mention apart from the charts that how the QQ plots or the quantile plots could be done. So, quantile plots or QQ plots, that point came up because if you remember that when we were discussing the charts, we did mention about the chi-square chart tables or chi-square distribution. So, those come up when you are trying to find out something to do with the concept of variance for the population, provided the variance of the sample is used to find out the best estimate. And then I also did mention, even though we did not solve, we mentioned about the F tables or the F distribution based on the fact that you want to find out something to do with the ratios of the variance or variability. Like as I mentioned, two products are being produced same type in two factories, in factory 1 and factory 2. In factory 1 the variability is very low, factory 2 the variability is otherwise either is much less or much more, and then you want to compare them. So, you can compare them using the ratios of the standard deviations of the populations, for which you replace the population standard deviation of the variance with the standard error or the variance of the sample and do the calculation. So, there you will use the F distribution with certain degrees of freedom. So, those laws of degrees of freedom would also come up in the discussion as you study those tables and the distribution. So, first as you remember, we want to find out the proportions defective. If you remember that whatever the distribution is binomial Poisson, considering the central limit theorem to be true, we replace that particular distribution with the normal distribution, but the fact remains that the normal distribution mean and the normal distribution standard deviation would be exactly to do with something with the actual population distribution based on which we are trying to draw some inference. So, if it is binomial would have a certain mean, certain standard deviation. So, those will be utilized to find out the central line and the upper control limit, lower control limit for the normal distribution, which is now so called replacing the concept of the binomial distribution considering central limit theorem to be true. So, first we estimate P, which is the proportion. So, this is in the problem we found out the total proportion was 347, and in each chunk you are taking 50 observation and such 30 observation sets of observations you took. So, obviously the overall proportions would be 347 divided by 1500, which comes out to be 0.2313. Then we estimate the control limits. So, then the control limits, again I am coming to the fact, let me try to highlight it in a much better way. So, what you want to do is that this P has been replaced by P bar or P hat, whatever you say, which is the average value. And if you remember, for the binomial distribution, we had taken the value of say for example, the mean and the standard deviation being given by NP and NPQ. Now, the question comes that once you replace those corresponding values for the population with the sample, obviously if you remember we had divided for the normal distribution the variance with n and basically took the square root of that and solved the problems accordingly. So, in the same way when you basically replace that using the central limit theorem and try to basically use those formula, it basically comes out to be n p, I will write the p q, or technically it is p into 1 minus p. So, though both those things are same, divided by n, then the square root of that. So, which means that basically it has something to do with sigma square by n, or the square root of this whatever you are considering. So, now in the normal distribution what we saw, it was the mean was mu, this was replaced by x bar n plus minus, that means if you are looking from your side, the central line is the central, which is x double bar, the upper control limit will be on this side, which is much more, and the lower control limit with the lower value. So, if you want to find out the dispersion, so called dispersion over and above, over and below the mean value, which is x double bar. So, you have to add some coefficient. Coefficient is basically a fixed number depending on the overall range which you want to have. So, if it is say for example 1 plus minus sigma, it will basically mean that overall coverage which you are doing would be about 67%. If it is plus minus 2 sigma, that means you are going plus 2 sigma above and minus 2 sigma below, it obviously the total coverages would be about 95%, and if it is plus minus 3 sigma, so the overall coverage would be about 99%. So, if you see the values of 3 which is given here, again I am repeating, that depends on the level of confidence which you want to have for the readings. And the values which I want to now highlight using yellow color, this part is basically exactly what we are talking about, in the case that you are taking the sample estimate in order to basically find out the so called control limits for the population. So, again coming back, the upper control limit becomes p gets replaced by p bar or p hat, which is the first information, which is the so called central line we are aware. Next, we have to find out the coefficient, which is 3 in this case, plus 3 and minus 3 depending on what level of confidence you want to have. Second is basically the so called standard error square of the sample, which basically comes out to be the case which is p into 1 minus p by n. So, if you want to basically find out the standard error, it will be square root of that. So, hence in one case it will be 3 multiplied by square root of p into q divided by n, and another case it will be minus 3 into p into q divided by n. So, based on the above calculations of the central values, which comes out to be upper control comes out to be 0.4102 and the lower control limit comes out to be 0.0524. You can basically plot the upper control, lower control and the central line as follows. So, the central line is this one, which I will just highlight using the red one without trying to disturb the diagram. So, this is the central line, and I will try to draw the upper line using green one. So, this is the UCL which is happening, which is 0.4102, and the lower value I will try to use the blue one. So, this is 0.0524. So, these are the values, between them you plot, then you can find it. There would be some values which are above and below the control limits, which is this one and so on and so forth. So, if you see the solution and try to solve it, this 15th one and the 23rd one readings are out of control. So, obviously, there are some problems related to assignable cause, unassignable cause, and you have to take corrective actions. So, it was found that point 15 and 23 were samples obtained from testing a new raw materials. That means, if the raw materials have come, maybe the moisture content is more, maybe the density is more, maybe the specific gravity has changed, maybe say for example the tensile strength is different. So, based on that there may be some reasons that why those 15th and the 23rd readings were basically out of control. So, yeah, let us continue reading it. It mentions that point 15 and 23 were samples obtained from testing a new raw material supplier and a new operator could have been also be there. So, say for example raw material is fine, it could have been like a new vendor is supplying it, or maybe the new vendor is sending the same product, but due to some mishandling the products are getting destroyed. So, we were discussing that assignable and non-assignable causes, and the reason could have been apart from the raw materials, apart from the vendor. Say for example, the vendor sends the materials, but the truck in which is coming has some dust particles. So, this could have affected the raw materials. Other can be the operator who is working is new, or his level of confidence on working on the machine is totally different from what was done by the other operator who used to work before. So, all these things could have happened, which would have affected the 15th and the 23rd reading, and based on that we can definitely say they are out of control. So, if in case if you want to be very sure that what are the reasons, obviously you have to take corrective actions, but for the readings you will remove these points and the limits will be recalculated. So, in case the 15th and the 23rd reading are removed, so obviously you will be removing two bunches, but the point will also remain that each such individual set of observations would have some sample numbers, so observation numbers. So, you have to basically remove those also, which means that if the 15th had say for example 20 observations and the 23rd also had 20 observations. So, 40 observations would be removed and the calculations for trying to find out P bar or UCL with respect to P bar, LCL with respect to this P bar, which is the new P bar I am talking about, would have to be done accordingly and the calculations done likewise. So, in the calculation if you remember in the last to last slide, the denominator had the numbers m and n, m was 30, n was 50. So, if I remove two of them, that means it will now 30 would become 28. So, in this case, but the sample size in each set of observations always remains 50. So, obviously your total set of observations initially it was 1500, now it will be decreased by 100, because now it becomes 1400 and you do the calculations accordingly. So, as shown here, the new points are recalculated. So, in this equation, let me highlight, this becomes 28, this was initially 30. So, you take out two observations, so it will be 28 here, plus when you find out this P bar, it will become 0.2150, which is this line where I am highlighting using the yellow color. When I calculate UCL, which is the upper control limit, again the coefficient 3 remains, P bar is 0.2150 and 1 minus P bar would be accordingly 1 minus 0.2150. This n remains same. Okay, yes, that is important to remember, because the chunk of observations, how many such chunks you took? 30. So, you remove 2, but the number of observation in each chunk remains 50. So, that 50 or n is not going to change. Based on that, I calculate the upper control limit is 0.3893, which is this line. Then the lower control limit, again you find out it comes out to be, let me change the color for ease of understanding. So, it comes to be this line, which is 0.0407, and if you find out the calculations, it will be very evident. So, let me use another different color, but now say for example violet. So, this is the new material or new operator or whatever the reasons are, you will be able to find out in a much better way and basically comment intelligently that what were the reasons for which this aberration occurred. Some consideration while designing the P charts is basically you have to find out the actual n and m based on which you will do the calculations. If P is very small, we should choose n sufficiently large, so that we have a high probability of finding at least one non-conforming unit in the sample. So, if your actual calculation is saying that the proportions is very small. So, obviously, you take a large chunk in order to find that. So, in one of the papers, very famous papers, Duncan has suggested that the sample size should be large enough that we have approximately about 50 chance of detecting a process shift of some specified amount. So, based on that you will find it out and do the work accordingly. So, this is the delta. So, L is the basically the number of psi or calculations based on which you can do the calculations, and delta is the magnitude of the shift. So, depending on the shift. So, these shifts are, let me highlight. So, you have the central line, this is the central line, this is the upper control line, this is the lower control line. So, as the shift, the central line remains the same, only shift which you have, let me use different colors to highlight that. So, this movement or this movement, whether moving positive or negative, would basically, positive means they are moving more away from the central line and moving more down, or they are coming closer, would depend on the values of so called p and 1 minus p and the corresponding values of n, and based on that you can do calculation. So, if the in control value of the fraction non-conforming is small, another useful criteria which is used to choose n large enough so that the control charge will have a positive lower limit. So, because 0 lower limit basically means that can be negative, obviously the difference of the ranges we are trying to find out would not be basically applicable here. So, what we are trying to find is proportions of the probability of the chance of the relative frequency. Now, relative frequency, chance, proportions, probability would never be less than 0. So, obviously, if they are 0 or little bit positive, then it gives us a much better feel that why we are using the charts, and we can understand through the readings how these values could be utilized. So, if we basically put this in the formula, so if you square it, so obviously it will be delta square, n would go on the top which is n, and this becomes p into 1 minus p, and L square comes, and then you solve it to find out the value of n, or a tentative value of n such that n value has to be greater than equal to that infimum value. So, here is a problem again from Montgomery. A process that produces titanium forgings for automobile turbocharger wheels is to be controlled through use of fraction non-conforming charts. Initially, one sample of size 150 is taken each day for 20 days. So, each day you continue taking it and you continue doing it 20 days, and the results are shown in the table, which is where I am pointing my palm. So, here you have day 1 non-conforming units is 3, then day 2 the non-conforming unit is 2, day 3 4, and so on and so forth till the last 2 days, which is 19th, non-conforming number is 3, day 20 non-conforming is 2. So, now with this information you have to establish a control charge to monitor future production processes, how it is going, and you also need to find out what is the smallest sample size that could be used for this process and still give us a positive lower control limit, such that we can use those control limits judiciously in order to understand whether the process is in control or out of control. So, that means more number of samples you take, it is better, it is good that you will try to do the study much more thoroughly, but the flip side is there is a cost effect involved. So, if it is destructive testing, obviously all the products are destroyed, or if it is testing where human beings, machines, manpower are involved, obviously there is a huge cost involved also. So, you have to basically judge accordingly, so that you can do the needful to find out the minimum value or the infimum value of n. So, the R code is given. So, you find out you basically have the matrix. Matrix would be basically the number of days and the number of non-conforming. So, based on that you put the numbers starting from 3 to 4, which is the third bullet point, 3 to 4 till the last two being 3 and 2, and you basically do the library function for the QQ plots. Based on that, when you have the QQ plots and you basically find out the tables, the central line is given by where I am highlighting. This is the central line, these upper control values are there, lower control values are there, and if you see the lower control values we are trying them not to be 0. So, if they are positive, well and good, but obviously in many of cases, even if you take a big sample size, it may not be possible to find out that for what sample size the value of the lower controlling limit would be greater than 0. So, the number of groups which you have taken is 20, central line as marked by the blue pen. The value which I will try to highlight is this one is 0.0167, standard deviation is 0.128, lower control value is 0, upper control value is 0.048, and if you want to find out if there are number of points above the central line or below the central line, they are basically 0 in number, because there are none of the points which are above here, none of the points which are below here. Obviously, on the lower side, now none of the values would be lower there, because they cannot be negative. So, that is why when we keep repeating that the lower control limit should be any value greater than 0, it will give you much thorough understanding whether the control limits. Obviously, upper values would be problematic, but if there are some values which are going the other way around, which is below the lower control limit, obviously it would give you some set of information how the process is doing. I am not saying they are out of control, but it will definitely give you some set of information. Now, based on that, when we use the formula to find out n, which is the minimum sample size, we use it to find out n should be greater than equal to the maximum integer value which you can have, 1 minus p divided by p l square. So, once you put it in our calculation, the value of n comes out to be about greater than equal to 533.167. So, obviously 534 would be taken as the sample size for this study. We will discuss now and pay attention to the NP charts. So, it is also possible to build a limit, central line, upper line and lower control line based on the number of non-conforming. So, now till now we have done the proportions means probability, relative frequency, chance. Now, I want to find out what are the numbers. So, obviously, if you are considering very simply, if p is the proportions are defective and if the total sample size is n, then the number of defective would be calculated by p into n. So, that would solve our problem, but that would give us some information in numbers rather than probability or chance, would be much more comfortable to understand in numbers. That is why you are trying to find out the charts and the property of the charts, the upper control limit, lower control limit, the central line, based on the fact that you are using the numbers, which is the sample size in the proportions are defective or non-defective, whichever we are looking at. So, it is also possible to base a control charts on the number of non-conforming rather than the fraction conforming. So, here fraction is not important, what is more important is the numbers. So, you have the central line again comes out to be n into p, actual central line. Obviously, if you do not have p, you will replace with a p bar. So, obviously, the central line would be n into p bar. So, finding out those upper control and lower control limit, the formulas concept remain the same, but the formulas would change depending on what you want to find out in place of the standard deviation, again using the central limit theorem. So, you have upper control as an NP plus or minus for the lower control limit, and the coefficient is 3. Now, the square root value which you have initially was p into 1 minus p by n, but in this case you will basically be utilizing the fact that you want to find out the variance and the concept would be utilized for the fact when you are interested to find out in numbers and not in the proportions. So, those values comes out to be np into 1 minus p, that square root, and plus minus 3 of that would give you the upper value and the lower value. So, if p is not available, obviously you will use p. So, this would be easy for us to understand. So, the case is basically p hat or p bar. So, if p is not available, p bar can be used, and it is easier to interpret, because I said that numbers are much more easy to understand than with respect to proportions or probability. Now, let us consider our NP charts. So, what you have is the sample numbers which are given on the leftmost column starting from 1 to 16. Number of non-conforming cans are given for sample number 1 it is 12, for 2 it is 15, and say for example for the last two, for the 15 sample number it is 22 and for the 16 sample number is 8. So, sample fraction non-conforming would basically be found out from this information set, and they come out to be 0.24, 0.30 for the first two, and while the 15th and the 16th comes out to be 0.44 and 0.16. Now, if I continue considering the sample numbers, they are like 17 to 30, the number of non-conforming cans are basically from 10 to 6, which is basically total is 347. And if I find out the sample fractions, obviously they would come out to be 0.20 to 0.12, and here the p bar value comes out to be 0.2313. So, now n is 50, n is the sample size, you multiply both of them, find out the central value comes out to be as shown here. So, I am just highlighting it. So, this you can find out at the central line, and the upper control and lower control would be found out by plus minus 3, and the standard deviation which you have in this case, considering that you are using the numbers as such, would be NP into 1 minus P the whole thing is square root. Again they come out from the simple concept of central limit theorem. Then you use those values to find out the upper control and the lower control. This upper control comes out to be 20.510 and the lower control comes out to be 2.620. Now, let us consider the fraction non-conforming control charts, and we want to find out the equivalent NP charts. So, the lot number is given from 1 to 10 in the first column, number of non-conforming belts which you are trying to test is given as 230 to 308 depending on the lot number, and again in the third column you continue the lot number from 11 to 20, and the number of non-conforming belts are basically given as 456 to 407. So, if I put the R code, the matrix basically would be again a 20 cross 2 depending on the reading number and what is the value. So, the values are given, which is 230, 435 till the last two is basically 221 and 407, and again you basically recall the same set of functions in R and try to basically plot the graph. So, here is the graph. The central line basically comes out to be about 307.05, which is highlighted here. And now you will see the lower control values would not be 0. So, you will basically find out it comes out to be as 257.814 and upper control comes out to be 356.2848. So, once you basically plot it, you will find out all the values are within the control limits as given. So, number of control limits and given, and I am coming to that. So, this red light points which are marked here, this one, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th. So, these are the ones which are outside the upper control and some are below the lower control, and the rest of the values which are basically black dots are within control. So, obviously, you will try to find out some reason, take them out from the calculations and try to basically redo your calculations accordingly. So, I will continue discussing more about TQM and the charts, and thank you very much for your attention. Have a nice day. Bye.